It is my pleasure now to invite Mr. Anand Patil, Head SDDC Sales, VMware India, to deliver the first special address of the day. Ladies and gentlemen, kindly put your hands together for Mr. Anand Patil.
Thank you. Is this working? It's audible? Great, thank you. So, I guess officially good afternoon and thank you very much for being here. My name is Anand Patil and I lead the networking and security business for VMware in India. So VMware is not typically a company that you'd associate with security products. But if you think about it, with the acquisition of AirWatch a few years ago and the amalgamation of that into our portfolio, we are now into device management. That lends itself to security from a device perspective. We're into our Horizon VDI solution, which lends itself to securing desktops in a very different way. And with the way, with our development of capability on the network virtualization side, what that gets to us is a unique perspective on how we can implement security within the cloud infrastructure offering that we have. And that's what I'm going to talk about and spend some time on today. So in the previous panel, we actually heard about digitization and what that's doing to the banking industry. A couple of points that got made in that particular discussion. One was around elasticity and scale, which lends itself to the cloud model of how monolithic applications, i.e. things like, is this clicker working? Give me a second here. Sorry about this. Thank you. There you go. So if you think about it, typical applications in the past, and typically this is how most of the banking core applications look today, they're monolithic in nature. This is like applications living inside a single tall building. Everything is integrated into a single infrastructure, your application, your UI, your DB, your storage, and the entry point into that infrastructure, into that application is a single one, much like the reception of a tall building. You can very much control who's going in and who's coming out of that building, which means you have very fine-grained control on all of these monolithic applications. But guess what? Arun talked about the capacity need that got generated due to demonetization. We saw banks needing 8x of the capacity on their payment applications than they needed before. All of that is giving rise to different application constructs. So if you think about what's happening in the application world, we are no longer constructing monolithic applications. We are looking at cloud-ready applications, cloud-native applications. And in the new architecture of applications, we have different components. We have the web layer, the app layer, the DB layer, and the storage layer. And these, because of x86 and cloud infrastructure, we're starting to see them being distributed across various components within our data centers. Now, cloud gives us multiple advantages: scale, elasticity, resiliency, manageability. But the moment you start talking about cloud, one big discussion is always at the center. How do you secure this thing? And if you think about what we've done so far in the technology world as IT people, how we've tried to secure our new application infrastructure on the cloud, be it your private data center or your public cloud, is that we've typically tried to segment these into application components. So we say, okay, let's take all of the web servers, put them in one zone. Let's take all of our database servers, put them in another zone, all the app servers in another zone, and so on. Why? Because they tend to have the same kind of properties when it comes to the application themselves, the code that's running on them. And we say, okay, their security needs can be grouped into a single zone. And thereby, I'm going to put them in a zone in my data center and secure them with a single kind of policy. Okay? For example, I'm going to say here that my web servers will not talk to the database servers without going through the application servers. My production systems do not talk to my dev and test systems, and so on and so forth. And after this, what I do is I secure the perimeter of my data center, which essentially means that I'm protecting against external threats. Okay? So on one hand, I've done zoning inside my data center. separated out all of the components, put policies on them. On the other hand, I have now started to protect my entire infrastructure from external threats. So far so good. Next, what I do is I implement host-based security. What is host-based security? These are essentially agents that run along with the application on top of every host. Okay? These are your host-based intrusion detection systems, antivirus systems, and so on and so forth. So life is good. We've got security implemented, right? Everything should be hunky-dory. But is it? Is this all? Well, obviously not. Because if you look at the statistics of breaches and hacks that have happened over the past years, I'll give you some examples. According to recent estimates, this was a study that was conducted and available publicly, the cost of a single breach has been pegged at an estimate of $4 million on an average. The total annual global cost of data breaches worldwide is $600 billion. That's a staggering number. That by itself takes it beyond the size of the illegal drug trade. So it's a big business, it's a big criminal business. It's very serious. Obviously, something is wrong in this picture, right? We've put so much security on the ground, we thought we secured ourselves from attacks, but still attacks are happening. So let's take a look at what exactly happens. How do these typical attacks take place? First of all, we've secured the perimeter. Okay, we put firewalls in there, we put network security in there, we are stopping unauthenticated illegal users from entering our infrastructure. However, how many of you have actually seen an attack that has been successful in the recent past that actually breaks through this barrier of external defense? How many attacks are targeted at your internet firewall, for example? Almost none. Why? Because that is typically not the target of sophisticated hackers. The first target is actually to compromise a person or an individual that works with the organization that actually has access into the data center. And typically this person is of some importance. He'll be an executive who's got a phishing email. It's very innocuous. And you know how this works. It's very simple. If you look at the kill chain of an attack, you will see that the first step in any kill chain is to compromise the security of a person and attach some malware typically through a phishing email and a link that gets sent as an email. Once you've done that, you have unlimited access into the data center, which is authenticated. So your perimeter security is no longer relevant. And once you're inside, there is almost nothing that stops you from going from one server to the next, one application to the next, one infrastructure to the next. Pretty soon, your entire data center is at risk because of one single breach, which is of an individual. So what I've just explained to you is an example where all of the security that we put in at the network layer has just been rendered useless. But you'll say, hang on, we still have the host-based security. We've got our IPSs, we've got our IDSs, we've got our antivirus systems that can detect abnormal activity. Well, guess what? The trust domain of all of these host-based systems is what? It's the host. Where is your application running? It is the host. The moment your host has been compromised, the first thing that the attacker can switch off or compromise again are these host-based security applications. If you've read the first page of the Economic Times today, this morning, on the forensic report that came out of the Hitachi attack, you'll see that the attack actually targeted the host-based systems. So they can be compromised very easily. Okay, fair. I mean, the sophistication required to launch such an attack is quite high. At the same time, there's no dearth of talent out there in the world in the criminal area, right? So there's something wrong with this picture. We've spent so much money on implementing security at the host level, at the network level, still attacks are happening. Okay? I'm not saying none of that is important. It's important for us to invest in these products and these solutions. But I want to point out a certain misalignment in the way that we're doing things today. On one side, you have applications. These applications define policies. These policies are related to the kind of applications that you're running and the users that need access to those applications. That defines what is the policy from a security standpoint that you are to implement for those applications. On the other side, you have the infrastructure where you have the controls. These controls have almost no visibility to the application, especially when it comes to the network, but we have to implement our security policies on this infrastructure. And thereby, we are actually creating a gap between where the controls lie and on what basis the policies get defined. That's where we feel, as VMware, we can make a difference. If you think about our legacy, we have been the fabric of the cloud. We have been the fabric that enables the cloud in a way that we create virtual instances of applications, and we lie there in the hypervisor, which is the abstraction layer between the applications and the underlying infrastructure. That puts us in a very unique position. The hypervisor, or this virtualization layer that I'm talking about, think about it. It's actually the third trust domain. Neither is it in the same trust domain as the application, nor is it in the same trust domain as the infrastructure. It's in between. Okay? It has visibility into what applications are running on top of it. It also has awareness of the topology underneath, what connections, what traffic is flowing from the applications to the rest of the VMs. And therefore, that puts it in a very, very unique place to start implementing things like security. The third and the most important thing that is a capability of this layer is automation. Now, we spoke about the scale at which we need to start implementing and rolling out applications to enable us to really face the challenge of things like democratization and the digitization that are coming our way. If we need to make security keep up with that pace, we need to ensure that security is also something that's ingrained into our implementation. Therefore, automation of security becomes a key enabler for us to do that. And this particular layer, which has been the fabric of the cloud, allows you to do things like kill a machine when you want to, bring up another virtual machine with the golden image automatically, okay? React to external conditions automatically. So what we're trying to do here, sorry, I think I missed a slide. No, that's fine. So what we're trying to do here is implement something called as the least privilege policy. And this is not something that's unknown. It's been around. In fact, this particular professor from MIT actually talked about it in the 70s, about how the simplest way to implement security is to actually implement least privilege. Give access to applications and users only what they need to do. So how do we implement least privilege using properties of the hypervisor? To get a little bit technical, let's talk about what the hypervisor actually does and how we implement microsegmentation using that. So the first thing is that when you are on the hypervisor, you're able to see what virtual machines are running, and you're able to see the network because you're connecting back to it. In between lies the virtual switch, which is nothing but a software-defined network element. On this software-defined network element, you can now start implementing security policies for every virtual machine and every network connection. You can actually do this on a very fine-grained basis such that you can surround a particular application with a policy that can segment it essentially at a level which was not possible before. Imagine the ability to put a firewall around every virtual machine that you're running inside your data center. Okay, that is unprecedented. We can do that only because we're in the hypervisor, only because we're in software. Not only that, what we enable is also an ecosystem of partners who work with us to enable advanced functionalities such as web application firewalls, intrusion prevention systems, and deep packet inspection that will work with us very seamlessly, making them essentially agentless, giving advantages of things like performance and transparency, where detection of these systems, these inspection systems in the path, is virtually impossible. Okay? So what we've now done, what we've now done is implemented a security mechanism inside the hypervisor. Like I said, this is probably the best place to do it. It's not in the application, it's not in the network infrastructure. It's in there where the network traffic does not really know that it's hitting this, it's passing this layer, but still it has visibility to everything. So we've implemented security at this layer, and we've implemented it at such a fine-grained level that was not possible before, and then we will be able to automate it. Imagine when you move a workload or an application or a virtual machine from one host to the other, or from one host to the data center, better still, from your private data center to the public cloud. Keep the security policies intact. The policies that you've implemented on that particular virtual machine, move along with it. That's the level of automation we are able to achieve today. So now you'd say, now that we've implemented this at the hypervisor layer, what about the underlying network? Because eventually all of this traffic has to flow through the underlying network, which is the physical network. And there, somebody might be snooping, so they'll be able to see credentials and things like passwords, and also be able to insert malicious traffic if needed. Well, the next step for us to do is introduce encryption, right? Cryptography has been existing around in the world for a long time. However, try to implement cryptography, and some of you in the audience might have done this. To implement cryptography and implement encryption requires typically point-to-point connections. And managing those point-to-point connections and the associated keys is a nightmare if you ever try to do it. What we've been able to do, because of the capability of the product that we're talking about here, which is NSX, is we will be able to implement dynamic distributed network encryption. We call it DNE. And what that allows you to do is encrypt data or traffic that flows from each virtual machine to the other. Okay? So now that you put a firewall, you've now encrypted all the traffic that flows between your virtual machines on the cloud, thereby protecting yourself from things like snooping attacks. So in summary, we've talked about microsegmentation as a capability. In fact, we have about, at last count, more than 2,400 customers of NSX globally. Microsegmentation is the primary use case that has been implemented by most of these customers because they see the value that it provides from a security perspective. Okay, I won't take much time. Where we see this heading, and I gave you a bit of a preview to that, is distributed network encryption so that we can encrypt traffic between virtual machines. The other capabilities that we have are securing end user connections, be they coming via VDI or from mobile devices. Going down further, we're releasing capabilities this year that will allow you to take this implementation of security on NSX and extend it to whatever public cloud you might want to take it to. We've already announced partnerships with Amazon and IBM, and we'll extend that further. We're coming out with such constructs for containers as well. So we see this as an area of great focus from our side. The interesting thing that we're also starting to do in this space is application detection and response, and this is quite different from a lot of the security products that are available out there. And I'll just give you a quick snapshot of what this actually means. Being in the hypervisor, we actually can detect and understand what is intended behavior for an application. Okay? And therefore, we can also understand what is unintended behavior when it happens. If we create a manifest of what is an intended behavior for an application, we can generate an alert every time there's unintended behavior, and we can respond to that using automation. You'll see more announcements on that as we go along towards the middle of the year. So in a nutshell, microsegmentation is something that we believe is quite key to being able to implement security in a granular and a scalable fashion, in an automated fashion within a cloud environment. And going forward, we'll extend that into other capabilities like application detection and response. Okay? And with that, that's my presentation. Thank you.
Thank you, Anand.